Hi friends and neighbors, welcome to the ShepNotes math video covering linear regression. There is no limit to the number of situations that can be represented by pairs of values or ordered pairs like x, y. In real-life examples, there may be hundreds or even thousands of pairs, but for this video, we will limit the pairs of data to 5 as shown at the right. In this example, the values in column X are the amounts of time on homework, and the values in column Y are the test scores each student received when they studied for X minutes. The student that skipped homework only got 20 on the test, but the student that spent 20 minutes on the test got a score of 100. A scatter plot graph is shown to give a better understanding of the relationship between study time and test scores in the example. When there is a perfectly linear relationship like this, the formula for the line through the data points is given by the slope-intercept formula y equals mx plus b. In this graph, the slope is 4 and the y-intercept is 20, so the formula for the line through the data points is y equals 4x plus 20. R is the correlation. R1 means the line has perfect positive correlation with the y values of the data points. Unfortunately, the previous example does not reflect the real world. Although increased study time improves test scores, graphs of the changes rarely fall on a perfectly straight line. Students get tired, distracted, or not serious about their studies. This causes the benefits of study to vary in a random fashion, something like the example shown here. Slope-intercept cannot be used to determine the line through these points because the slopes between each set of points changes, causing the resulting line to be jagged like the red dotted line shown. To get the best straight line through the points, a regression line is used. A regression line is the line of best fit between a series of data points. The better a line fits the data points, the better the correlation between the line and the data points. R equals correlation. In the example at the top, there is a good correlation between the study time and the test scores. In the bottom example, there was a very poor correlation between study time and test scores. Some of these students seem to be limited in their abilities to learn or were not committed to really learn the homework as they put in their time. Two different XY relationships are graphed along with their regression lines with the formulas y equals 4.2x plus 14 and y equals 2.1x plus 18. The correlation for the top example is very good at r equals 0.987757, so you can use this to get a good estimate of the expected scores for study times along the line. For example, if you wonder what score might be expected if you study 14 minutes, replace x in the formula and you will get close to y equals 2.1 times 14 plus 18, which is equal to approximately 76.8. The correlation for the example at the bottom is not very good at r equals 0.52698. You can use the formula y equals 2.1x plus 18 to get a rough estimate of the expected scores for any study times, but the actual results can deviate from the calculated value more than they would in the first example with a better correlation. If you wonder what score might be expected if you study 14 minutes, replace x in the formula to get roughly y equals 2.1 times 14 plus 18, which is equal to approximately 47.4. In the previous examples, there is a positive correlation between the study times and test scores. Now suppose the homework is designed to teach material that is contrary to the questions in the test in an effort to change the student's opinion. The most successful students in the class get the lowest scores, while those that skip the homework haven't changed their opinions and get the highest scores. In this case, R equals minus 0.96762, which indicates a negative correlation, which means that as the study time goes up, the scores go down. Correlation is the relationship between two variables that contain a series of data represented by ordered pairs like x, y. X is the independent or explanatory variable, and y is the dependent or response variable. The strength and direction of the correlation between two data points is measured with the correlation coefficient, R. For those who are curious or might need it, the formulas for R and the regression line is given next. If these formulas look intimidating or boring, ignore them and don't panic. After the next discussion, I will show you how to display the correlation coefficient and the regression line for a set of data in Excel with a few simple keystrokes and without any complicated mathematics or calculations. On this page, the formula for the correlation coefficient and the regression line are shown. Pause the video if you are interested in studying this page. The formula for the correlation coefficient is shown at the top of the page. The correlation coefficient is represented by R. The square of R, the correlation coefficient, has a special name. R squared equals the coefficient of determination. It turns out that R squared, or 0.9757 in this example, indicates that 97.57% of the offset of each data point, the score versus time, is explained by the relationship of score and study time. The remaining offset is not explained and is due to sampling errors, chance, ability of the students, etc. As promised, let me show you how you can use Excel to graph a scatter plot diagram of an XY relationship. To keep it simple, we will use the example used in this video, the relationship between study times and test scores for 5 students. After collecting the data for the students' test scores and homework study time, start a new spreadsheet in Excel. Label cells A1 and A2 X and Y. In cells A2 to A6, enter the study times, and in cells B2 to B6, the corresponding test scores. Set the background color of cells A1 to B1 to blue and all surrounding empty cells to black. Pause the video as needed. Set background color of cells A8 to B8 and A10 to B10 to a color like orange. Enter R in A8 and R to the second power in cell A10. In cell B8 and B10, enter the formulas shown at A on the screen. Notice that A2 to A6 in the formula is the data for study time, and B2 to B6 is the scores for the 5 students. CORREL is Excel's function that returns the correlation coefficient, R, for the 2 lists of data in the cells A2 to B6. R to the second power is the coefficient of determination. Pause the video as needed. To display a scatter plot diagram, select the range of cells A2 to B6, which contains the study time score data. On Excel's Insert tab and the Charts section, select the first scatter chart in the Scatter drop-down to display this chart. Before moving on, select the label Series 1 and hit the Delete key. Pause the video as needed. Right-click on one of the data points. In the context menu, click Trend Line. With the linear option at the top selected in the dialog box, check the Display Equation and Display R-Squared option at the bottom and close. The regression line, its formula y equals 4.2x plus 14, and the value for r squared are displayed. Notice that r squared is equal to the value that we calculated earlier with Excel's built-in function. I colored and provided a zoomed copy of the formulas so that they could be seen easier. Hi friends and neighbors. Thanks for watching the ShepNotes video on math and regression. Watch for the next video that will be available soon.